Hi again, everybody. This is lesson 4 of trigonometry. It's called solving right-angled triangles. And as usual, I'm going to call mine answer key. And here's the warm-up. Today we'll combine the last couple of topics in order to solve word problems and triangles using 3 tools of trigonometry. Each of the following tools requires that you know different things about the triangle you are trying to solve. So the first tool is the Pythagorean theorem, and that says that c squared is equal to a squared plus b squared. With this tool, you are using it to find a side of the triangle. You must have 2 of the other sides. In order to use this tool. Number 2 are the primary trig ratios. That's sine, cos, and tan, and it follows the little acronym SOHCAHTOA. With this tool, you are using it to find a side or an angle. You must have 2 sides or 1 side and 1 angle. To use this tool. And finally, number 3 is the angle sum of triangle tool. In any triangle, guys, the 3 angles add to 180 degrees. So angle 1 plus angle 2 plus angle 3 equals 180 degrees. Okay, with this tool, you are using it to find an angle. You must have 2 of the 3 angles in order to use this tool. Note, tools 1 and 2, the Pythagorean theorem and SOHCAHTOA, can only be used when you have a right triangle. Okay, so those 2 tools are only good in right triangles. You have a right triangle, and of course a right triangle is one that has a 90-degree angle in it. So a little 90 like that. Okay, so these 2 tools are only for right triangles. Okay, tool number 3 works in any triangle. Okay, so in any triangle, the angles have to add to 180, and we know that from geometry as well. Okay, let's try example 1. For each of the following, find all the missing angles and sides. Okay, and so for A, there are 3 things that are missing. We have to find the measure of angle M. We have to find the length of this side, let's call it X, and the length of this side, Y. You'll notice that we have 62 degrees here. This little box means that this angle is 90 degrees, and then we've got that side that's 15 millimeters. Okay. So if we know 2 of the angles, guys, it's pretty easy to get angle M because the angles have to add to 180. So what you do to get angle M is you go 180 degrees minus 90 degrees minus 62 degrees. Okay, and if you do that, you are going to get that angle M is 28 degrees. So let's write that in there, 28 degrees. And we need to find the length X and the length Y. Okay. So there's a couple ways that we could do this. We could use the angle 62 that they gave us, or we could use the 28 that we found. If we use angle 62, then the triangle would be labeled like this. This would be the opposite side. This would be the adjacent, and across from the 90 is always the hypotenuse. And so I have the opposite side, and I want to find the adjacent. Which ratio deals with opposite and adjacent? Look at this SOHCAHTOA acronym. OA is opposite and adjacent. That comes from tan. So I would go tan of 62 degrees is equal to 15 divided by x. And remember, when we have an equation like this, these two switch. So x is equal to 15 over tan 62. Mode, I'm in degree mode, good. So I go 15 divided by tan 62. And I get 7.97. If we go to 1 decimal place, that 9 would get rounded up to a 10, and that would become 8.0, and that's going to be millimeters. Okay, so we figured out x, and now we have to figure out y. So if we continue using angle 62, the opposite side is the 15, and y is the hypotenuse. And which ratio deals with opposite and hypotenuse? That would be sine. So we go sine of 62 degrees is equal to, the opposite is 15, and the hypotenuse is y, and then those are going to switch to get y by itself. So I go 15 divided by sine 62, and I'm going to get basically 17. So I'll go 17.0 millimeters. Okay, so down below here, angle M we got as being 28 degrees. MD, if I go from M to D, that was the length Y that we got, and so that is 17 millimeters. And U to D goes from here to here. That was labeled as X, and for X we got 8.0. So we've got 8, 15, and 17. If we look at Pythagoras, 8 squared plus 15 squared, does that equal 17 squared? Yes. Okay, so that looks good. Okay, let's try letter B. For each of the following, find all the missing angles and sides. So we've got this 90-degree box here. We don't know this angle, let's call it alpha. We don't know that angle, let's call it beta. And we don't know this side, DG here. Why don't we call it X? All right, so if you want to get x first, we have a 90-degree triangle, so we could use a squared plus b squared equals c squared. And remember, across from the 90, this is c. And so this can be our a and this can be b. So we would just go x squared plus 12 squared is equal to 13 squared. So x squared plus 144 is equal to 169. Subtract the 144 from both sides. X squared is equal to 25. So that means x is equal to plus or minus the square root of 25, which is plus or minus 5, but we are going to reject the negative because we're finding the length of the side, so x is equal to 5 centimeters. Right, so up here, at this step, you have to go square root with a little plus or minus in front. Okay, so this GD is x, that's 5 centimeters. And now let's figure out some angles. Maybe we could start with, I'm going to need to pause here for a second, guys. Okay, I'm back, everybody. Somebody just came to my door. All right, now let's figure out maybe angle beta. Yeah, this one right here. Okay, across from the 90 degrees, we can kind of maybe get rid of some of our symbols here now. And I'm going to put, we got this side as being 5. Okay, across from the 90 degrees, this is the hypotenuse. And if I'm talking about angle beta, then this would be the opposite side, and this is the adjacent. Okay, and so we could use the numbers that they gave us for accuracy. So adjacent and hypotenuse, that comes from cos. So I would go cos beta equals 12 divided by 13. And to get angle beta, we would just go cos inverse of 12 over 13. Shift cos 12 over 13 and press bang. About 23 degrees. And now that we know that this is 23 degrees, we knew that that was 90 all along, we can get angle alpha by going 180 degrees minus 90 degrees minus 23 degrees. And I believe that is going to be 67 degrees. Yes. Okay, so angle D is the one that we labeled alpha. That is 67 degrees. Angle O is the one we labeled beta, and that was 23 degrees, and we just solved that triangle. Excuse me. Okay, here's example 2. A man standing on the top of a 130-meter cliff fires a cannon down at a ship sailing 800 meters offshore. Find the angle of depression of the cannon, then find the distance the cannonball traveled before it sunk the ship. Okay, so let's do this. Here's the cliff. Water. Ship. Okay, so the man is standing on top of a 130-meter cliff, so this is 130 meters. Fires a cannon down at a ship sailing 800 meters offshore. So we're like this, and we're going to fire this down. And it says the ship is 800 meters offshore, so this is going to be 800 meters along here. There's our 90-degree angle. Find the angle of depression of the cannon. So remember, the angle of depression is the one that is down from the horizontal dotted line. So this is actually the angle of depression. Let's call that alpha. It's not inside the triangle. Okay, so we're actually going to have to figure out what this angle is first, beta, and then use that to get alpha, the angle of depression. Okay, and then find the distance the cannonball traveled before it sunk the ship. So the cannonball has to go along this diagonal straight line. So they want us to find this distance here as well. Okay, so first of all, the angle of depression, we have to get angle beta first. And straight across from angle beta would be the opposite side. And across from the 90 is the hypotenuse. So this is the adjacent. So I have the opposite side and the adjacent. And if I think about SOHCAHTOA, which trig ratio deals with opposite and adjacent? That's tan. So I would go tan of beta equals 800 divided by 130. And so beta is tan inverse of that. So angle beta is shift tan, 800 divided by 130, and we get about 81 degrees. So this is 81 degrees. So then the angle of depression, remember from the dotted line to the cliff, that's going to be 90. So I have to go 90 minus this 81, and we get that alpha is 9 degrees. So the angle of depression is 9 degrees. And now we have to figure out d, that distance. So we can erase some things here. And we can go a squared plus b squared equals c squared. This is a, this is b. Across from the 90 is the hypotenuse, which is c. So if I were to go c squared equals a squared plus b squared, the c is what we've labeled distance, d. So d squared is equal to 130 squared plus 800 squared. And what is that? 130 squared plus 800 squared, which is that 656,900. And then we can go d is equal to plus or minus the square root of that. D equals plus or minus 810.5, and we would reject the negative because that's a distance, so d, the distance the cannonball travels, is 810.5. What are the units? Everything's in meters, so that's meters, and that's what I will put down here, 810.5 meters. Okay, there you go, everybody. That is lesson 4. It's solving right-angled triangles, using a lot of the stuff that we learned before in lessons 1, 2, and 3, so it's good review. Okay, so here's the assignment. Everything looks pretty good in here. So I would encourage you to try this assignment. And as usual, I think maybe you're starting to see the pattern. I send out video lessons and assignments on Mondays, and by the end of the week, usually about Friday, I will send you an answer key, and you can check your answers. And there is also an answer key at the end of the notes here. and I will probably send you a quiz pretty soon for marks, and we will go from there. So I hope you are all doing well, everyone, and hopefully we can see you soon back at the school. But for now, we're just going to continue with this online learning. So there you go, and I will be in touch soon.